Hello students, my next topic is resolution of a vector or rectangular components of a vector in a plane. So we have a plane which is consists of x and y coordinates. Okay, now resolution of a vector. Now we have a vector like this. We want to resolve this vector into two components. Okay, we want to find the two components of this vector and we want to resolve this vector into two components. This vector resolution of vector is opposite to vector addition. Okay, in vector addition what happens, we add two vectors a and b and we get the resultant. That's what is called vector addition. We have two vectors, let's say a and b, we add them, we get the resultant vector. But when we find the resolution of a vector, that means from the resultant we find the two components of its vector. This is a resultant and we resolve it into two components. We write this vector r in terms of sum of the two vectors. Okay, so this is the inverse of this is the opposite of this. So resolution of a vector is opposite to the vector addition. Here we have a single vector which we divide into two components, a and b vector, or ax, ay, or ax vector. Okay, for example, here see a and b vector. We have chosen ax, ay in place of a and ax in place of b. So we have a single first we have a coordinate. Okay, so this is in 2D in a plane, so it is a 2D. So we have a vector or which is in a plane xy. Okay, so or vector, we call it a. Or vector is vector a. Okay, now this vector can be resolved into two components, ax and ay. So ax and ay are the two components of this vector a. Okay, so ax we draw it along the x-axis and ay we draw it along y-axis. So this is the length of ax, ay, this is the length of ax, and ax vector is making an angle theta with the vector a. This vector makes an angle theta with the vector ax. So what we are doing here, we are resolving this vector a into two components, ax and ay. This is what is called resolution vector. We can always do it. We can always resolve any vector into two components in a plane. Okay, if we had 3 dimensions, then we can resolve this vector into 3 components, ay, ax, ay, and az. Okay, in a plane we can resolve into 2 components. Okay, so here vector a can be written as ax plus ay. Okay, vector ax plus vector ay. Now ax, again, if we want to write this in terms of unit vectors, then we can write ax, magnitude ax, which is this much, and direction I cap for x direction, and for y direction we can write ay vector as ay and j cap. Okay, ay and j cap. So from this we can write, from this figure we can see that this ax equals to a cos theta. If you use this triangle, then cos theta equals to curly brown here, so b by h. We get cos theta equals to b by h, brown here. No, b is ax and h is a. Therefore ax we get a cos theta. Similarly, if you find the sine theta of this, we get ay equals to a sine theta. Okay, you can easily find it. Sine theta, some people have p h. So p is again ay. This pr is same as ay. Therefore ay equals to a cos theta. Therefore you got ax equal to a cos theta, ay equals to a sine theta. And if you square this, a square x plus a square y, which is equal to a square cos square theta plus a square sine square theta. And if we take the a square common, then we get cos square plus sine square theta, which is equal to 1. Therefore we get a square equals to a square x plus a square y. Okay, simple. So we got ax equals to a cos theta, ay equals to a sine theta from the figure. Okay, then we square this two term and we sum it up, a square x plus a square y. Similarly, a square cos square theta plus a square sin square theta. Then we take the a square common and this term becomes 1. Therefore we get a square equals to a square x plus a square y. From there we get a equals to square root of a square x plus a square y. So this is the magnitude of vector a. Now this was vector a. This is vector a. If you are asked to find the magnitude of this vector a, then we have to use this formula. So a magnitude of a is equal to the square root of magnitude of a square x plus magnitude of a square y. So this is the formula for to find the magnitude of vector A. Vector A. Now we'll find the direction of this vector in terms of theta. Once you find the theta, we get the direction of this vector also, no? So we have to find the theta to find the direction of this vector A. So how can we find this? We know ay by ax equals to a sin theta by a cos theta. So a cancels out. Finally get tan theta equals to ay by ax. From there we get theta equals to tan inverse ay by ax. You can use any vector, okay, sin theta also you can find, but usually we use tan theta to find a direction, and theta equals to tan inverse ay by x. So this is the formula for direction of vector A. So tan theta equals to ay, tan theta equals to tan inverse ay by ax. Okay, now theta gives direction of vector A.